Hello and welcome to our MassQL tutorial. MassQL, or the Mass Spectrometry Query Language, is an incredibly powerful tool that allows you to search for patterns in mass spectrometry data. So why use MassQL? First, MassQL is expressive. Whether you're searching for MS2 peaks, charges, retention times, neutral losses, or all of the above, MassQL has options to look for just about anything you want to see in mass spectrometry data. It's also precise, meaning that it will only return the spectra that exactly match your query. And while writing MassQL queries can take a little bit of a learning curve, you'll soon find that they're very easy to read and easy to learn. They're also flexible, which means that you can share, refine, and modify your queries to make the most of expert collaboration within your organization. Finally, and perhaps most importantly, MassQL is scalable. This algorithm can search through thousands of mass spectrometry files in seconds, getting your results faster and saving your precious analysis time. So how do you create a MassQL query? Well, the first thing you do is determine whether you want the algorithm to return MS1 or MS2 data. Here we're returning MS2 data, which is likely what you'll be doing most of the time. Next, you'll choose your search parameters. Here we're looking at an MS2 peak, or MS2 product, at 339.27 m/z. But MS2 peaks are not the only thing you can search using MassQL. You can also search MS1 peaks using MS1MZ, neutral losses using MS2NL, specific scan numbers using scan-min or scan-max, charges, retention times, ion mobility, etc. Once you've determined your search parameters, you can then refine these parameters using qualifiers. Qualifiers allow you to define mass tolerances using terms such as tolerance MZ or tolerance ppm, and minimum intensities using terms such as intensity percent and intensity value. These qualifiers can be chained to create even more exact MassQL queries. Once you've determined your search parameters and qualifiers, you can start to chain searches using the terms and or. This allows you to search for, say, multiple MS2 peaks or an MS1 peak that is associated with a specific neutral loss, etc. I'm sure you can already imagine just how complex these queries can get. For example, here is a query searching for glycerophosphocholines by looking for 4 different MS2 peaks with specific mass tolerances and minimum intensities. This query looks for sulfated molecules by looking for MS2 peaks with a mass difference of 79.9568 m/z. This query looks for iron-binding molecules by looking for MS1 peaks that are within 2 m/z of each other and have a specific intensity ratio that is characteristic of iron binding. We have a lot of examples in our documentation as well as open source examples from the MassQL compendium and the MassQL publication, but for now, let's check out how to run a MassQL query in Ometaflow. The first way to run MassQL in Ometaflow is through the standalone workflow. You can access this workflow using the Workflows tab here or the Launch Workflows button here. Simply search for MassQL and click Launch Workflow. Here you'll need to enter a job description and then select your input data. Input data must be mass spectrometry files in MZML, MZXML, or MGF format. To add files, simply click on the file or click on the folder containing the file and click Add Selected File to Input Data. You'll see your selections here. We'll go over these optional selections later, but for now, let's just run a MassQL query. Today we'll be using that glycerophosphocholin query that I mentioned earlier. You may notice that I've changed the intensity values a little bit because I'm using different data than the person who originally created the query. To begin, simply click Submit Workflow. Now this workflow took about 30 seconds to complete, and now we can start to check out the results. The first table here is your query list, which lists out every single spectra that matched to your query. You can find a lot of information about these spectra in this table, but if you want to learn more, you can always click on View Spectrum to open up the spectrum in our spectrum resolver and get a nice list of MS2 peaks. Or you can click View LCMS to view the entire TIC plot for that sample, as well as an XIC plot, MS1 and MS2 spectra for your compound of interest. While a standalone workflow is an excellent way to rapidly identify compounds of interest in your samples, I think MassQL is most fun when it's paired with molecular networking. To do so, go to one of your molecular networking tasks and scroll down to the downstream analysis section and click on the MassQL query button. This will pull up your workflow, and you'll notice that all of the input data files are already selected for you. Now all you need to do is enter your query and click Submit. Once again, this workflow took about 30 seconds, And now we have the option to visualize the full network in browser by clicking this button here. This will bring up your molecular network and allow you to highlight nodes that matched your MassQL query. To do so, go to the node size option here and click Enriched Query Index 0. Query Index 0 indicates that this was the first MassQL query that you ran. You can run multiple MassQL queries in a single workflow by separating the MassQL queries with 3 horizontal lines like here. But since we only ran one MassQL query for this workflow, we only have the option of Enriched Query Index 0. In this network, you'll see that we have 3 matches to our glycerophosphocholone query, and unsurprisingly, they all network together, indicating that they have structural similarity. But let's say you want to do a quick search without having to run the whole MassQL workflow. Well, from the molecular networking browser, you can always scroll down and enter your MassQL query in the MassQL highlight box here. This will tell you if you have a valid MassQL query, and will also highlight any nodes that match your query in the network without having to perform the MassQL workflow. So that's it for our MassQL tutorial. Thanks for watching.